Hello, this is the prototype for a high resolution audio capable Bluetooth speaker. The speaker system consists of two parts: the drivers or the speakers that consist of the left and right channel and a subwoofer, and the electronic section. In the right and left channel, they consist of two separate drivers. One is a 4-inch woofer for outputting mid frequencies, and the other is a 2.5-inch tweeter, which is this one, or we should rather say a 2.5-inch paper cone driver, which is required for generating high frequency audio output. Similarly, there is also a 4-inch subwoofer enclosed in a band pass enclosure for low frequency audio signals. Now the connection from all the three driver units is fed to this electronic section. The electronic section consists of a Bluetooth module. Currently we are using CSR 8645 for audio decoding of aptX codec based high resolution audio signals. But if we want to keep it completely 100% open source, we can opt for ESP32 based open source Bluetooth chipset. Now the output from the Bluetooth codec goes to the digital compounder board, which consists of digital potentiometers and a microcontroller. The algorithm contained in the microcontroller is responsible for analyzing the input signal and the preamplification signals, and to detect any clipping in the signal and remove it by adjusting the signal's tone control through the digital potentiometers. Now the output from the digital potentiometer goes to the preamplifier section, which consists of two things. One is a preamplifier section for the left and right channel, and the other is the preamplifier section for the crossover, which is then fed to the amplifier section of the subwoofer. This module is also responsible for providing the feedback to the microcontroller for analyzing the audio signal at each amplification stage. Finally, the preamplified audio signal, which consists of the 2.1 channel, that is left, right and subwoofer, is then fed to this amplifier section, which consists of a class AB amplifier chip, and the output is then finally fed to these three speaker enclosures. The whole system is run from a single ended power supply rather than a dual voltage transformer based supply. This helps in later adapting the entire system to be able to run on DC batteries or lithium ion rechargeable batteries in future. The only change that we have to make in this prototype is to replace the amplifier section from class AB to a class T if we want to change the system to a battery operated system, and that is because class AB amplifiers generate a lot of heat, which will result in wastage of energy, whereas class D amplifiers are highly efficient when compared to class AB, but they struggle in generating high frequency output signals. That is why we are currently using class AB. But if we later want to make a battery operated or a rechargeable lithium ion battery based system, we can always opt for a high quality class D power amplifier chipset. Thank you. I'm now going to connect the adapter to the wall outlet in order to start the system. As you can see, the compounder has started. Now there is a button here which will if I will press will reset the onboard microcontroller. That I will demonstrate when I'll start the speaker. So I'll now pair the speaker with the another phone. As you can see, the speaker has connected with the system and is currently using AAC codec. If you will use a high-end phone, we can even connect it using the aptX codec. I'll now start the playback. As you can hear, the audio quality from the speaker is very clear as compared to the other Indian made counterparts. Now in order to demonstrate you the difference, of what the digital compounder makes, I'll now play the music again, and while the music is playing, I'll disable the compounder by pressing that button. As you have seen in the video, disabling the microcontroller and the compounder logic results in degradation of the audio output. This shows that the compounder design is working in an efficient way for generating clear audio signals. If there are any questions, please feel free to contact us. Thank you. This system was made by FutureTech Embedded Solutions OPC Private Limited.